Hmm. So, good morning.
Good morning, sir.
Your screen is visible. Are you able to see the
Yes,
screen?
sir.
Okay.
Yes, sir.
We left with only one topic in the model 3, if I'm right. So, only induction generator is to be covered. Okay. That I will do in some other class. Okay. So, now I would like to complete the remaining part of that model 1, where it was two important topics were left over there. Okay, 3-point and 4-point starter and speed control of DC motors. So these two topics are not covered there. So here I would like to cover this 3-point and 4-point starters in today's class, and in the remaining classes I'll be starting the speed control of DC motor. These two are important topics as far as model 1 is concerned. Okay, model 2 is completely we have covered, nothing is left, and model 3 only one question is remaining. In the model 1 some portion is left over there, so two topics. Okay, we have details today about speed control, and in today's class we'll discuss about 3-point and 4-point starters of a DC motor. Okay, so before we move on to the starters, so what is the necessity of starter? The first thing is, what is the necessity of starter? Necessity of starter for DC motor. What is the necessity of starter for DC motor? You have to first you have to explain this one. Why you have to use starter for a DC motor? Okay. Why we cannot connect a DC motor directly across the supply? What happens if we connect directly? Okay. We know that the basic operation is like this. If you just consider this as an armature, okay, armature of a DC motor here, and for a DC motor, what is the input we are giving here? Here the supply voltage is given. Okay, voltage is applied because electrical to mechanical. We are giving the supply voltage due to which current IA flows here. IA flows armature current. Okay. First, it will act as a motor. Okay. When you give the voltage, armature current flows, field current flows, it acts as a motor in the beginning. Once it, after motoring action, there is a generating action also inside. It develops a voltage which we call it as a back EMF. Okay. It is developing inside a back EMF, and the direction of this induced EMF in opposition to the applied voltage V. According to Lenz's law, it opposes its own cause, isn't it? So back EMF is developed. EB is called as a back EMF. Okay, EB is developed, which opposes the applied voltage and as well as current also. According to Lenz's law, the direction of induced EMF, electromagnetic induced EMF, in such a direction that it always opposes cause producing it. This is there because of V. Once we applied V, then only inside back EMF is developed. Okay. So, and if it is having a resistance of Ra, armature having a resistance of Ra. Okay. Now, so what is the current taken by the armature? What is the current taken by the armature? The current IA is given by the armature current is the net voltage across the armature. Net voltage across the armature divided by armature resistance. What is the net voltage? Here this is applied like this, and back EMF will be opposing the cause producing it. What is the net voltage then? V minus EB by RA. Basically, I equal to V by R. So what is the current taken by the armature? IA is equal to net voltage by armature resistor. V minus EB divided by RA. This is the equation for current taken by the armature. From there, we can find EB equation also. So what is the current taken by the armature now? IA is equal to V minus EB divided by RA. So I'm trying to explain this why we need the starter here. Okay. So initially what happens when back EMF is developed, when the motor start rotating, then only back EMF is developed. Okay. Initially at the time of starting, what is the back EMF? Zero. What is the back EMF? Zero. Then what is the equation now becomes? Only it is V by RA. V by RA. Because at the time of starting, back EMF will not be there. Okay, when back EMF is not there, it is equal to 0. Therefore, IA equal to V by RA. I am considering an example of 5 HP motor. Okay, and its operating voltage is 220 volts. Armature resistance is Ra is equal to 0.5 ohm. So I'm considering this motor. Okay. What is the capacity? 5 horsepower, 220 volts, armature resistance is 0.5. Now, what is the current taken by this? What is the full load current of this motor? IFL is equal to power by voltage. What is the power? It is 5 horsepower. It is 735.5. 1 horsepower is equal to 735.5. 5 horsepower is equal to, just multiply with 5 into 735. You'll get the power rating divided by 220. Therefore, current is equal to power by voltage. In DC, power is equal to voltage into current. The power is what it is, 5 horsepower. We know that 1 horsepower is equals to 735.5 watt. I'm converted into watt horsepower. So now what is the full load current of this motor? Calculate it and
16.71, sir.
okay, 16.711 ampere. So what let me make it 17 amps. The full load current of the DC motor is 17 amps. That is a maximum load the motor can able to take. But if you don't use the start, this is what happens. This is the full load current. Now, if you are not using any starter, then what is the current taken by the motor? Now it becomes how much? V by Ra. What is V? 220 divided by Ra. Ra is 0.5. Therefore, current taken by the motor at the time of starting will be 440 amperes. 440 amperes. Then how many times it is greater? If you divide by 17, so it will take how many times more current? Nearly 26 times. Yes. 440 by 17. Full load current is
25.88, sir.
okay, almost 26 times more current it will take if you don't use the starter. If you're not limiting this high current at the time of starting, the current taken by the motor will be 26 times more. Think of it. What is the maximum current the motor can withstand is only 17 amps. Let us say 20 amps maximum. But what is the current it is taking at the time of starting? 440 amperes, which is almost 26 times more. What happens to the brushes, commutator, okay, windings, insulation, all gets burns. Okay, it damages the commutator, it damages the brushes, it damages the windings. Okay, so such a high current, it is 26 times. You think of that, 20 amps, whereas more than 400 amperes. That's why we should limit this high starting current. Why only at the time of starting? Because at the time of starting, back EMF will be 0. Otherwise, back EMF will control. It will not allow the current to enter. Okay, it opposes. When back EMF developed, the moment we start, the moment armature start rotating. Okay, until and unless no EMF is induced inside that. At the time of starting, back EMF is 0. At the time of starting, EB equal to 0, therefore IA equal to V by RA. What is the full load current of motor? If you consider this the 5 horsepower motor, it's only 17 amps it can able to take. But if you don't use a starter, if you don't limit, because RA value is very small, we must connect an extra resistance here. Otherwise, it will take dangerous current. Okay, this is the necessity of starter for a DC motor. Okay, any doubts in this? Okay, what is the necessity of starter for a DC motor? Okay, is it clear now? The net voltage across armature is V minus EB by RA. EB equal to 0. So initially at the time of starting, back EMF is 0. If back EMF is there, it will control. During normal running condition, back EMF is only the controlling factor. Okay, depending upon the load, it controls the armature current from the supply, depending upon the load and speed, isn't it? It makes the motor self-regulating one. But what about at the time of starting? Back EMF is 0. That's why the current taken by the motor will be dangerously high. So somehow we have to control by connecting a starter. What is starter basically is? It is you know that right now if you consider 3-point starter, all of you are familiar with this 3-point starter. You have seen the even used also in the laboratory. 3-point starter. What it is having? Basically, it will have a 3 terminals. That's why name is given here, isn't it? 3 terminals L, F and A. L means it is connected to the line. F means it is connected to the field, and A means it is connected to the armature. Okay, it is connected to the armature. Now we have to limit the high starting current here. Okay, we have to limit the high starting current. Here we are giving the DC supply. This variable resistor is nothing but almost it is already RA is there. We are adding extra resistance here, RS. So total resistance becomes now RS plus RA. Okay, 3 point means L means line, it is connected to the line. F means field, it is a Z field. A means armature. 3 points are there, 3 terminals. That's why it is called 3-point starter. RA equal to RS plus RA. RA is very small value, so we are connecting a high value of resistance in series. Okay, along with two protective devices. Okay, it is like this. There will be a variable resistance like this. A large value of variable resistance will be there. Okay, and there will be different points, studs we call it as 1 2 3 4 5 6 different studs, copper studs will be there. Okay, inside that it is a half position, and there is a handle also. There is a handle here. Okay, and it is having soft iron piece here attached to this, and this is the spring. And it is connected to the supply. It is connected to the supply. It is a half position. It is RS. That's what variable resistor. It is nothing but a resistor is connected in series with the armature. It is connected in series with the armature. This is the armature like this. Okay. Armature. A resistor is connected in series with variable resistor. That is nothing but a starter, along with two protective devices. We are using two protective devices. They are called, this is the one coil which is called as a no volt coil, NVC we call it as no volt coil, or it is also called as hold on coil. This is also called hold on coil. Hold on coil. NVC, no volt coil or hold on coil is there. And there will be one more coil which we call it as a overload release coil. One more is there, overload release coil. Two coils will be there, overload release coil and no volt coil. I will show the diagram. Okay, these are all connected like this. There is a field also. 3 terminals, L, F, A. This is the L supply. Okay, it is a handle which can be moved. You can see that. I will show that. We can move this one over the resistances, different tappings. Okay, initially the resistance, full resistance is included to the armature. Okay, as we are moving to the stud number 1, stud number 3, now current flows only like this. This much of resistance is not included. The moment it comes to stud number 1 here, what happened? This much of resistance is not included. What happened? The small amount of current start flowing. By the time motor starts rotating, the moment motor start rotating, back EMF will be start developing. So as we are moving towards right, stud number 2, 3, 4 like this. So what happens? Slowly we are decreasing the resistance. Thereby the motor speed is increasing. It is developing back EMF. That back EMF will take care of the extra. It will not take more current. Okay. Initially full resistance should be included in the circuit. Okay. And when the moment it comes here, what happens here is the hold on coil. It holds the handle. It holds the handle. It's electromagnet. Two electromagnets are. This is the OLR coil, overload release coil it is, and another is a NVC coil. Protective devices. Along with a series resistor, two protective devices are used here. And 3 terminals are L, F, A, and A. And here during the normal operation, when it comes to here, full load on position, full on position, there is a soft iron piece here. This is attracted to the electromagnet. By the time it has become an electromagnet, because it is connected in series with the field. Field current is flowing through this. So what happens here? It becomes a magnet. It holds the soft iron piece. So against the spring control, because we are moving this handle against the spring force, it is try to restore back to the off position always. So where it holds under normal, it is designed in such a way that it holds. So whenever what happens, whenever you want to switch off, okay, you want to make it off, so suddenly it gets demagnetized and it comes back to half position, because it should be always in the off position whenever you want to start. Every time whenever you want to start, it should be in the off position. Otherwise, what happens if it is here, no resistance is included, current directly flows to the armature. Current directly flows to the armature because this resistance is excluded if it is here only. So that's why you have to pull it back. It automatically comes back when it gets demagnetized. If not, we have to pull it back manually. Some obstruction is. These are the copper studs will be there. And this is the resistance, high value of resistance made of nichrome or anything. And copper studs will be there. These are called button-like structure. They are called studs, copper studs. Okay. So this is the no hold coil or hold on coil. The purpose of hold on coil is holds the handle. Okay. It attracted through soft iron piece here. Whenever it's switched off, it will demagnetize and it releases back to the off position. Sometimes what happens, this one more coil is there, OLR coil, overload release. As the name indicates, overload. Whenever motor is drawing more than its capacity of the current, so this what happens is this will get magnetized. It is lifted up. When it is lifted up, this soft iron piece, this will get demagnetized. Okay. Whenever this is lifted up, so over current flows through this extra current. That extra current makes it magnet. So because of that magnet, it is lifted up. So it short circuits the no hold on coil. So it demagnetizes. When it demagnetizes, it is back to the off position. Suddenly it comes to off position. Thus, the motor is protected against overload also. This is clear now. So this is the 3-point starter, what you call it as. Okay, 3 points are L, F, and A. Is clear. A variable resistor is connected in series to the armature along with two protective devices. Overload release coil and no hold coil or hold on coil, as the name indicates. Okay, it is having one drawback. Okay, one major drawback of 3-point starter is, so we know that speed is inversely proportional to what? Flux, isn't it? In order to increase the flux above the rated value, in order to increase the flux above 1500 RPM, let us say, we have to decrease the flux. Flux has to be decreased. If we decrease the flux, because here, see, field current is flowing through this magnet only. If it is connected in series with the no volt coil, this is important. What is the drawback of 3-point starter? See, what happens, in order to increase the flux, when you want to use it for a high speed application, we have to decrease the flux. When you decrease the flux, what happens here? The flux, this whatever this magnet is producing, the flux will get decreased. When the flux decreases, its magnetic property also decreases. So soft, this iron handle, chances of coming back to the off position. This is the major problem. So whenever you want to use it for high speed application, we have to decrease the flux. In order, if we decrease the flux, the electromagnet get affected here. Its magnetic property get away. Okay, so it will not have a strong magnetic force to hold the soft iron piece. It releases because it is already hold against the spring force, because we are moving towards right against the spring. So that's why it holds. It should have a good force of attraction. So here, when flux decreases, current flow, this is decreasing, flux decreasing. When flux decreases, its property of attracting force decreases. So this is the problem. To overcome this problem, we are going for a 4-point starter. One more extra current limiting is connected. Extra resistance is connected. Okay, LN, we call it as the terminal as N. It is connected in parallel with the field coil. Okay, that is called 4-point starter. It's clear. Extra current limiting resistor is connected here. So this will not have any problem. Even when you operate at a more than rated value, the motor is protected against that. It will not get demagnetized or reduces the force of attraction. Okay, so I will share one video. Just you can watch this video and we'll come back to it. 2 minutes video is there. Just watch. Yeah, can you able to see this video? Hello?
Sir.
So here you can see this is called hold on coil. So I'm showing here, no, this Hello?
Yes, sir.
These are called studs, button-like structure, what you can see here. 1, 2, 3, 4. See handle, they are moving the handle, you can see from start position to here moving. We are using this in the laboratory also. So this is called hold-on coil, which holds electromagnet. It is a one electromagnet, it is another electromagnet. Two electromagnets are there. Okay, what is showing, it holds the handle under, see it is holding also electromagnet. Soft iron piece is held by this magnet. There are internal connection. These are the copper studs are there. Okay, when it gets demagnetized, suddenly it comes back to the half position. Under normal working condition, it always holds. And even when the overload is occurring, so what happens, this gets short circuits, so this gets magnetized, this gets short circuits, and this coil is demagnetized. There is a connection between this. See, he is showing now. So this is what it is lifted up. Sheet is showing. This is the showing now. This is what you can see. It is lifted up. When it gets lifted up, this coil gets short circuits and it comes back to opposition. Okay, and three terminals are L, A, F. Okay? Line, armature, and field. Okay, these are called copper studs, actually button-like structure. As we are moving, one resistance is not suddenly decreased. Step by step, it is decreased. As we are moving towards right, the resistance is go on decreasing. Current flow increase, and back EMF will develop. Okay, instead of directly connecting armature across the supply, so this is the protective devices are used here. Okay. So I'm just yeah. Can you able to see this? Hello.
Yes, sir. Yes, sir.
This is a neat diagram. What you can see, this is a 3-point starter. Yeah. Can you able to see this?
Yes, sir.
Yeah, the same explanation what I did, I explained already. The same thing it is there. Okay, here three terminals are L, F, and A. L, F, A. F means it's connected to field. A is the armature, and this armature is connected in series with the variable resistor. This R, is it? And 1, 2, 3, 4 are the studs. What I shown in the video, copper studs are there, and it is a handle. But you can see it is a and there is a soft iron piece also here. It is a spring. It is connected connected to the line terminal. Current flows like this only. And as a handle is moved here, the current flows directly like this. This much of resistance is not included. And when it is here, no resistance is included. Under normal working condition, you can remove the total starter. No need of starter. When it is normal working condition. Why? Why we can, even though if you remove the starter, it runs safely. Why? Under normal working condition? Anybody can tell? Hello? Under normal working condition, even if you remove the starter, it runs safely. How? Hello?
Line is directly connected, sir.
Okay. The moment armature start rotating, back EMF is developing. No, that back EMF is opposing. Back EMF will not take more current from the supply. Initially, when it is in the half position, then only the current taken by the motor will be dangerously high, isn't it? This is the 3-point starter. What again? There are two. This is called hold-on coil. Holds the electromagnet under normal working condition. It's a overload release coil. Okay. Whenever extra high current flows, so what it gets magnetized. This is a triangular portion. We can see it is lifted up. When it is lifted up, it is short circuited. That makes the hold-on coil demagnetizes. When it gets demagnetized, it is off. Motor off. Motor is protected against high current flowing through the armature. Okay, so that is what the working is, the same thing what I explained. Everything is there. There is a no volt coil or hold on coil. Okay, NVC, it gets magnetized. Okay, now when the handle is run position, one is a half position, another run. Soft iron pole is connected to the handle. Because of the flow, the current flows through it. It gets attracted by the magnetic force produced by the no volt coil. Now it is designed such a way that it holds the handle during the run position against a force of spring. As long as supply is given to the motor, the NVC holds the handle in the run position. Okay. So, and when you remove the supply, it gets demagnetizes. And even there is a overload release coil also. These two you must write in that. Okay, two important functions of overload release coil, right? No volt coil. Overload release coil is a small electromagnet, as the name suggests. It is used to give the protection to the motor in case of overload. Under normal condition, overall carries armature current. This current is not sufficient, you know that. But when the armature current exceeds normal value, it attracts the lever, okay, and the triangular portion, what you can see, NVC gets short circuited, that release the handle because it gets demagnetized. Here you can see. This is the triangular portion is there, no? It is lifted up, extra current. When the extra current flows through this electromagnet, it becomes a magnet that attracts the soft iron piece. It will get short circuited and it demagnetizes it back to the hot position. Thus, it is a overload protection. Okay, a drawback of 3-point starter. Just read it, what it is. Just go through it. Just 1 minute, you read it. Yes, understood. The same thing what I explained. When it is used for high-speed application, the 3-point starter suffers from a serious drawback for the motors, a large variation of speed by adjusting the field rheostat. See, we know, I already explained, flux control method is used to control the speed above the rated value. In that case, what happens, you know, the field current, in order to increase the speed, we have to decrease the flux. That means field current has to be decreased. To increase the speed of the motor, field resistance can be increased. Therefore, the current through the shunt field is reduced. Field current becomes very low, which results in holding electromagnets too weak to overcome the force exerted by the spin. So what happens is that the amount of that magnetic force produced by electromagnet or no volt coil is not sufficient to hold the soft iron piece. The holding magnet may release the arm of the starter during the normal operation and thus disconnect the motor off, switch off. This is not desirable. Okay, it is because under normal working condition, when you want to use to have higher speed applications, this is undesirable. A 4-point starter is thus used instead, which does not have this drawback. Okay, so next we have I understood this one. What is the drawback of 3-point starter?
Yes, sir.
Okay, any doubts?
No, sir.
Okay, understood now. Okay, right. Now coming to the 4-point starter. So what is the difference we are finding? Same, everything is same. No difference at all. You can observe the diagram. What is the extra you are finding here?
N, sir.
Extra is N. N is nothing but it is extra resistance is added. I'm showing here. Can you able to see this R? Hello?
Yes, sir.
This R, current limiting resistor, which is connected in parallel with the field. So this magnet will not have that problem. Okay. This is also connected. You can see this through this directly connected across the supply. This will not have any problem in the event of even the flux variation will not affect here. Flux variation will not affect. Okay, because it is connected. You can see this resistance is connected in series with the supply here. Okay, and which is also connected to the field, not a problem. But compared to the previous case, here it is safe. Okay, the field current will not get the field current. Earlier it was flowing through only one path. Now there are two paths for the field current. Okay, so now whenever even the flux decreases, this will not get affected. Okay, there is another path for the current to flow back to the source. So there is a 4-point starter, what you can say. In case of 4-point starter, NVC is connected independently. Okay, no, see, it is independently connected. Earlier, it is connected in series with the field. It is connected, see this. It in 3-point starter, it is connected in supply and then it is to the series field. Okay, but here in the 4-point starter, it is connected independently. See, this is independently connected. It's this way you can see. This connection helps independently across the supply as a 4th terminal N, in addition to line, field, and armature. So extra N is there here. Okay, protective resistance here. As a direct consequence that any change in the field current does not bring about the difference in the performance of NVC. As I told you, no, any variation in the flux will not affect here. Thus, it must be ensured no voltage coils always produces the force which is strong enough to hold the handle running position against a force of spring. It will not come back to the half position. Such current is adjusted through the no volt coil. Such current is adjusted to the no volt coil. Help the fixed resistance is used here, R. Okay. Or again, it is connected in series with the field winding. So thus, this is the same diagram you can practice. One extra resistance is added here. That's same explanation. Only explanation what you read, these 3 points you have to write. In case of 4-point starter, the no volt coil is connected. Okay. This is the extra, that's a major drawback of a 3-point starter. When you want to use it for high speed applications, you have to reduce the flux that affect the operation of handle. Okay. This handle releases its capacity. Okay, to overcome this problem, we are going for this one. Okay, practice 3-point starter perfectly, and extra wire you have to connect independently, and write those 3 points. Okay, is it clear now? Any doubts with respect to starter? The same explanation what I told you, know, stud number 1, and then the resistance go on decreases, and when it in the run position and off position, 2 positions are the run position and off positions. When it is at the run position, it is a normal working condition. Again, it is a spring control. And you use it now already in the laboratory. It is a box-like structure, isn't it?
Sir. Yes, sir.
Yeah, this is the box-like structure. So you already used. Any doubts in this? First, I explain what is the necessity of starter. Why you have to go for the starter? Okay. This is the necessity of starter with the example. We have to explain this. What is the necessity of starter? What is the current taken by the motor at the time of starting? Otherwise, back EMF is very interesting phenomenon. I hope what is the significance of back EMF? See, the significance of back EMF is very interesting. See, what happens here? N is directly proportional to back EMF and inversely proportional to flux. If back EMF is there, it will no need of starter. But at the time of starting, back EMF will be 0. That is a problem. See how it controls, you know that. So it depends on what it is, armature current. Okay. See, when the load on the motor, what will be the load on the motor at the time of, say when you put less load, what is the speed? See, if one person is moving in a two-wheeler, speed, 3 persons are moving, what happens to speed? Decreases. That's what, when you are putting less load, what is the speed? Speed will be more, isn't it?
More, sir.
Now, what about the back EMF?
Decreases, increases, sir.
See, when the load is less, speed is also speed is more, back EMF is more, you can see. And it takes less current from the supply because there is no need of current. There is no need of current because load is not there. When the load is not there, speed is less, speed is more. So back EMF will be more. What is another way of saying back EMF more means more opposition to the current. It will not take more current from the supply. Is it clear now? When the load is less,
sir.
Speed will be more, back EMF will be more, opposition is more. Because no need, because load is there means it will take more current. On the contrary, if you put more load, what happens? Speed decreases, back EMF decreases.
Decreases.
Okay. When back EMF decreases means what? Opposition decreases. It takes more current from the supply. So depending upon the load, it takes the current from the armature. This is controlled by back EMF. And that back EMF depends on speed because it is directly proportional to speed. Speed depends on load. Like this, the back EMF will makes the motor self-regulating one. Depending upon the load, it takes the current from the armature. But at the time of starting, back EMF will be 0. That is a problem. The moment you move the stud number 1, back EMF will develop. Okay. Stud number 1, the back EMF is developing. Okay. Any doubts with respect to starter? Is it clear now? What is the necessity?
Yes, sir.
Okay, you have to illustrate with this example. How much time it takes? More time, 26 times more current it is taking. If you're not connecting an additional resistance, extra resistance, RS, it will take, because RAV is very negligible. RA 0.05, 0.01, something like that. Okay, it cannot limit the current, high starting current. We need an extra resistance of high value in series only at the time of starting. Okay, the moment it start running, no need of start. You can remove it off. Okay, is it clear now? Any doubts in the 3-point starter, and what is the drawback of 3-point starter, and what is the advantage of 4-point starter? Okay, diagram is saying extra one more connection you add to the 4-point starter. That is the difference what you can observe. Is it clear now?
Yes, sir.
Right. So what about that second experiment for this Saturday? Sir has shared in Google Classroom. Swinburne test will be there. Swinburne test for this week's experiment. We have Swinburne's test. Okay. Sir has shared. Vijay Krishna sir has shared this video and
No, sir.
write up not shared.
No, sir.
This is also called no load test. This is a simple test where we are recording only voltage is already, we have to adjust the speed, no load current and supply voltage. That's all. Only 3 parameters are recorded: voltage, speed and no load current. Okay, and if you want you can also tell ISH also, ISH not, I not, speed and voltage. Only 4 parameters are recorded. Okay, that I think the sir will explain, and I will tell the sir to share the video and as well as a simple experiment. Okay, this is the experiment is suppose you have to do in this week. I will tell the sir to share the material as well as video also. Okay, so we in the next class we discuss about speed control techniques. We have speed control of DC motor. Okay, various techniques are the 3 methods we can control the speed. One is a flux control method, second one is a IARA method, armature voltage control method, and third one is voltage control method. 3 methods are there: flux control method, armature voltage control method and supply voltage control method. And we have to explain for 2 motors. One is a series motor, we have to explain all the 3 techniques, and shunt motor along with some numericals. These things we have to discuss. This is important concepts which are required in the final year also. Okay, so that we'll discuss in the followed by. And if time permits, I'll do that induction generator. One topic I left in that, induction generator. Okay, this also I'll be covering. Induction generator means it is used in the windmills, which works at negative slip. Okay, the rotor is run, you know that slip is equal to what? Ns minus n divided by ns. Here the rotor speed is above the stator speed, rotating magnetic field. If ns is say 1500, if the rotor is run at 1600, so what will be the slip now? We'll get a negative slip here. See this higher value, n is greater than ns. N is greater than ns. Rotor is run above the rotating magnetic field ns. We get a negative slip. When the negative slip is there, it acts as a generator. Instead of motor, it acts as a generator. So that we'll discuss in time permits. Okay. So we have completed this 3-point starter today, and you wind up now. I will continue in the next class. Any doubt with respect to this? I have to share the material. I will share the material also for this third model. And I will give the assignment. I will post assignment by tomorrow only. Write the assignment. Second assignment I will be sharing this.
Okay, sir.
Any doubts with respect to that subject? So if you can able to do the speed control methods, all the techniques, that completes 3 models perfectly. I have not left anything. 3 models. I'll wind up now. Okay.
Thank you, sir.
All right.